class, I am Sneha Sujith. Today we are going to discuss the chapter Laws of Motion. In the previous classes we have discussed about motion parameters, equation of motion, etc. Right? So while coming to this chapter, we are going to discuss about the cause of motion. So what is the cause of motion? The cause of motion is force. So what do you mean by a force? Force is an external form of push or pull. So now let's discuss about the effects of force. Suppose this is a surface and I'm keeping this pen over here. Now the pen is in the state of rest. I'm applying some force on this pen. What happens? Now the pen is in the state of motion, right? So this is the first effect of force. The force will produce or tries to produce motion in a stationary object. The next situation is somebody is coming towards me and I am applying a force in the opposite direction of the motion of that body. What happens? The motion of that body will cease, right? So the next effect of force is the force will stop or tries to stop a moving body, right? The next situation is, suppose we are playing football. If I need to change the direction of the ball, what will I do? I used to kick the ball, right? So while kicking the ball, I am applying a force on the ball, right? So that force will change the direction of the ball. So the next effect of force is, the force will change the direction of the ball. So these are the effects of force. Now let's classify the force into two based on the nature of interaction. The first one is contact force and the next one is non-contact force. So what do you mean by contact force? Contact force is the force experienced between two objects when they are in direct contact. Direct contact. Okay. Suppose this is surface and I am keeping this pen over here. This surface will exert some force on this pen, right? So what do you call for that force? Normal force. So that normal force is an example for what? Contact force. So tension is the next example. Spring force is also an example. Frictional force is another example. Okay. So while coming to this non-contact force. What is non-contact force? The force experienced between two objects when they are not in actual contact. No actual contact exists. Okay? Fine. Suppose this is a pen. I am dropping this pen from a height. What happens? The pen wheels comes down, right? Why? There is a force experienced between earth and this pen. What do you call for that force? Gravitational force. So gravitational force is an example for non-contact force. Why? The pen and the earth are not in actual contact. So gravitational force is an example for non-contact force. The next example is, suppose this is a magnet, okay, and this is an iron ball. What happens? This iron ball will the magnet will attract this iron ball, right? So that means there is a force exists between these two objects. What do you call for that force? Magnetic force. So magnetic force is an also example for non-contact force. The other example is electrostatic force. Okay. So in simply we can say that a force is required to move a stationary object or to stop a moving body. An external agency is required to provide this force which may or may not be in contact. So okay, so what about moving air? What about a body moving in a uniform motion? Do you think that an external force is required to keep a body in uniform motion? This seems to be very simple for you, but it takes a long years to answer this question. In 384 BC, a Greek thinker named Aristotle held a view that an external force is required to keep a body in uniform motion. he held the view by considering the practical experience. He had no basis on the opposing forces. In 17th century, what happened now? In 17th century, scientist named Galileo had proved that the view held by Aristotle was completely wrong. He had proved this by doing an experiment called double inclined plane experiment. Let's have a look into the experiment setup. So this was the setup held by Galileo. Okay, so what Galileo did? Galileo had released a ball from the first inclined surface, and the ball rolls down and climbs up and attained a height, final height, which is nearly equal to the initial height. Later he again decreased the slope of second inclined plane, and he had repeated the same experiment. The ball rolls down and climbs up and attained a height which is nearly equal to the initial height. But there is some difference in these two cases. What was the difference? In second case, the ball has travelled much more distance comparing to the first case. In limited case, when the slope of the second inclined plane is 0, what happens? The ball went on moving. It was trying to find the initial height. Or in other words, we can say that the motion of the ball never ceases. Okay? Until it is attaining a height which is nearly equal to the initial height. Simply Galileo concluded that no net force is required to keep a body in uniform motion. Okay. After that, Galileo introduced a new term in physics. That is inertia. So what do you mean by inertia? Inertia is an inherent property of a body by virtue of which they can't change the state of rest or of uniform motion in a particular direction by themselves. Suppose there is a body at rest. This body has a tendency to remain in the state of rest only. That property is known as inertia. Suppose there is a body which is moving with a particular velocity. That means this body is in the state of motion. This body will have a tendency to remain in the state of motion only. That property of this body is called inertia. See the third example. Suppose this body is moving in a particular direction. Okay? Then this body will have a tendency to remain in that direction only. That property is also known as inertia. Okay. Simply we can say that inertia is something resistance to change. Okay. The next thing is inertia is not a physical quantity. It is just a property which depends upon mass. To make this concept more clear, I'll give you one example. See, this is a block of 5 kg which is at the state of rest, and this is a block of 5 kg which is moving with a velocity 10 meter per second. So which one will have more inertia? Obviously both will have same inertia. Why? Inertia is only depend upon mass only. Here the two bodies have same mass. That means both have same amount of inertia. Okay, fine. So now let's classify the inertia into 3. The first one is inertia of rest. The other one is inertia of motion. And the next one is inertia of direction. Okay, so what do you mean by inertia of rest? Inertia of rest means it is the inability of the body to change the state of rest. Okay, it is the inability of the body to change the state of rest. So we can learn the inertia of rest by giving some practical examples. Okay, the first example is when you're traveling or when you are in a bus, standing on a bus which is at the rest, and the bus starts to move suddenly. What happens? You will feel a jerk in the backward direction. Why? Initially, the bus was at the rest and your lower body has a contact with the bus. When the bus starts to move suddenly, your lower body is also coming to the state of motion along with the bus. So what happens to the upper body? The upper body remains in the state of rest only. That means you will feel a jerk in the backward direction. And we can explain the same case. While we are shaking a mango tree, what happens? The mango falls down. This is also due to inertia of rest. What happens? In the initial condition, the mango and the tree are in the state of rest. The mango has a contact with the branch. While we are shaking that tree, what happens? The branches come into the state of motion. And what happens to the mango? The mango will continue to be in the state of rest only. So it gets detached from the branch, and due to the gravity, what happens? The mango comes to falls down. Right? Okay. Now let's discuss about inertia of motion. There are a lot of practical examples which you can experience under inertia of rest. Okay, try to find and learn the physics more interesting. Okay, so inertia of motion. Inertia of motion is the inability of the body to continue in the state of inertia is the inability of the body to change the state of motion. So what is that? What can you give an example for inertia of motion? Yeah, if you are traveling in a bus which is moving initially, that means your lower body has a contact with the bus, right? So your lower body is also in the state of motion. Suddenly the driver applied some brake. Okay, so what happens? The bus comes to the state of rest. So your lower body also comes into the state of rest along with the bus. What happens to upper body? Your upper body tries to continue in the state of motion only. So you will feel a jerk in the forward direction. Okay, the same case you can observe that while we are jumping out of a moving train, what happens? Initially the train is moving, right? And your lower body is in contact with the train. It is also in the state of motion. So while jumping out of the train, what happens? Your lower body suddenly come into the state of rest. Why? The platform have a state of rest only. What happens to the upper body? The upper body tries to continue to be in the state of motion. There also you feel a jerk in the forward direction. Okay. So these two are the major examples for inertia of motion. You can find a lot of practical experience in this condition also. Inertia of direction. It is the inability of the body to change the direction. See, if you are traveling in a car which is moving in a straight line, suddenly the driver takes a sharp turn. What happens? You will feel a jerk in the sideward direction. Why? Your lower body is in contact with the car at the initial time. So, it have a direction in the straight line path. Suddenly the driver takes a sharp turn. The lower body attains the direction of the car. But what happens to the upper body? The upper body tries to continue in the previous direction only. So you feel a jerk in the sideward direction. Okay. And one more example. Tie is torn at the tip of a thread and you start a whirling motion. Suddenly at a particular instant, I I'm cutting this string. What happens to the stone? Will it comes down directly? No. It will follow a tangential path. After cutting, it won't be able to continue its whirling motion. It will continue a tangential path and later it gets thrown off to the ground. Right? So these are examples for inertia of direction. You can see a lot of practical experiments in all of these three cases. Okay. Thank you.